Hello, this video is going to cover GPIO and IRQ in QEMU development. So again, in this video we're going to cover IRQs in the form of QEMU IRQ and GPIOs. So IRQs allow communication in and out of a device without using memory. They act as a GPIO pin or just a generic signal. They are in QEMU. We use QEMU underscore IRQ. Sysbus devices have a special handler for them. They use Sysbus underscore init IRQ, which can create a IRQ that connects directly to an NBIC or interrupt handling system, but otherwise works the same as any other IRQ. So with QEMU IRQ, there are several built-in methods. We have set IRQ, which is the most used. It just sets the IRQ to a value. We have raise, which sets it to 1. We have lower, which sets it to 0. We have pulse, which sets it to 1, then 0 in quick succession. Invert will take whatever the input was and invert it. And then IRQ is connected will return if the IRQ is actually connected or not. Every IRQ has 3 main components. It has a number, a handler, and a level, and we will discuss each of those in a minute. So GPIOs, QEMU organizes the device I/O using GPIO. Everything under the hood is a GPIO, even the Sysbus IRQs we discussed earlier. So to create them, we use 2 different things. We have init GPIO out and init GPIO in. On the left here, or on the right here, you can see a couple of different devices creating their GPIO pins. So before we get into the depths, we need to discuss named versus unnamed GPIO. QEMU allows you to group GPIO pins under a name, which is a string, a C string. The pins, if you create a pin using this function over here, that's just the get GPIO, or the init GPIO out without, there's another version with underscore named. If you don't use that version, it actually just gives it a name, literally the string unnamed. But so if you wanted to get that using this, you could just use unnamed here in this part with the quotes to get the unnamed in. But you don't need to, because you can just leave out the underscore named part. So the QDev init GPIO in. This initializes a GPIO input pin. It takes 3 parameters. You have your device state pointer, which is the device that you want to create the GPIO for. It has a function handler. It's a unique type called a QEMU IRQ handler, but it basically just takes a opaque pointer to some state and the number of, like, the IRQ number, and then the level that it was being set to. So yeah, that gets run when the state changes using the set. Using any of these, it will call the handler. And then the last argument is the number of pins to initialize. Okay, here's a handler. You can see it takes an opaque pointer, which we can just translate into a Wi-Fi state, and then the IRQ number and the level. So, and yeah, the number of pins to initialize. So that can be more than 1 if you are initializing an array of them, for example. The other function we have is QDev init GPIO out, which initializes a GPIO output pin. It also takes 3 parameters, 4 if you are going to name it. It has the device state pointer for the device that you're creating the pin for again. It has a pointer this time to a location in memory, and then the number of pins to initialize. This time we're using an array, so S out we have here. So we're saying, hey, create 12 GPIO pins and put them in this array so we can use it later when we want to, like, raise or lower it. using those functions from before. So now that we've created our GPIO pins, we can connect them up using a couple of different functions. The first, qdev get GPIO in, will let us get an input pin from outside of a device. So for example, this is a line in the TM4C main file that gets a ADC's GPIO pin, an input pin. It's in an array, or it's in a loop, so it has an I, and then the J is another IRQ number for the splitter device. And we connect them. Then connect is qdev connect GPIO out. It allows us to connect an input pin to another device. And we often use these in the same thing like this, where you'll get the GPIO pin and then use it to connect immediately. Okay, so qdev get GPIO in. There are two arguments, or three if we're using the named version. The first one is going to be the pointer to the device state, and then the second one, if you have it, is the name. You don't use it here, and then the IRQ number is the third one for the GPIO line. As you can see, this is getting a IRQ from the NVIC, so this is just another example of why everything under the hood is IRQs, or is GPIOs. Even the sysbus IRQs that we were using for our interrupt handlers. Moving on to qdev connect GPIO out, there are three arguments, four if we're using named. So this one uses named. We have the device state pointer. This is the device we're connecting to. Getting the GPIO output pin and connecting that to. The name of the group. This has a name, Rx underscore name, is just another variable. Then we have the IRQ number, and then the pin to actually connect, in which case we just used the output of the qdev get GPIO in call. So a bit more about IRQ numbers. They are unique to grouping, not a device, which means every name group, including the unnamed, gets its own set from 0 to n. So you can have, let's say you have a name group pin 1, and that pin 1 can have 15 GPIO pins. It'll have 0 to 15, or 0 to 14. And then you have another group, just unnamed, that'll have 4 pins, and it will have 0 to 4. So 0 to 4 exists in both unnamed and that hypothetical pin 1 group, but they are different. Same thing with inputs and outputs. They are completely separate. So an input pin 0 is not going to be the same as an output pin 0. We can, and keep in mind that these are set by calling order. So in this example, we have created 12 input pins, and they're going to do the ADC AIN trigger, and then 3 more that do trigger 2. In this case, we have input pin IRQ number 0 through 11 that calls the ADC IN trigger, versus 12 through 14, which calls ADC AIN trigger 2. This is completely different than if we were to do it the other way around, where we have the 3 on top, because then 0 through 2 calls the trigger 2 function, and 3 through 14 calls the trigger 1 function. So keep that in mind when you're programming. Since we have GPIO pins that we want to talk about on the TIVA board and the inside QEMU as itself, we will, from this point on in our videos and write-ups, name them separately. We have named the QGPIO to refer to the GPIO pin we talked about in this video, the QEMU IRQ stuff, and then just regular GPIO will refer to actual GPIO pins that we want to emulate from the TIVA board itself. So that's all there is to talk about GPIO pins and IRQs. All of this information and more is shown here in our emulator write-up. The other video in this series was about these devices, machines, sysbus devices, and interrupt requests, and this was this video discussing the GPIO pins. Thank you for watching.